In this video, we're going to be looking at the Aufbau Principle, Hund's Rule, and the Pauli Exclusion Principle. First, the Aufbau Principle, which comes from German for building up. So, according to the Aufbau Principle, for any atom that's in the ground state, the electrons are going to fill orbitals in order of increasing energy, starting with the lowest and then going up from there. So, let's consider, say, boron. So boron is going to put 2 electrons in the 1s, and then it's going to have 2 electrons in the 2s, and then it's going to have an electron in the 2p. It has 5 electrons, so at this point, that's it. That's all it has. But notice we filled first the 1s, and then the 2s, and then the 2p gets an electron. Now, is it possible to have an electron jump up to a higher state? Yes. But it will be violating the Aufbau principle, and it'll be in what's called an excited state. That's something for a little bit later in this unit. Next is Hund's rule, and this states that every orbital in a sublevel will be singly occupied before any orbital is doubly occupied. And it also says that all the electrons in singly occupied orbitals will have the same spin. Now, the second thing, you pretty much have to memorize it. Just remember that all spin will be up or all spin will be down. The first rule, or the first part of it, I think you can make an analogy to, if you go to sit on a bus, if it is possible for you to be sitting on your own bench, you probably will. And we could say that that's because you want your space. Electrons also want their space, or they would if they could think. But they're all negatively charged, and because they're negatively charged, they should experience a repulsion. So, if we are considering, for example, say oxygen, well, we can put 2 electrons in the 1s, and then 2 in the 2s. Now the 2p, let's see, oxygen should have 8 electrons, so we have 1, 2, 3, 4. We need 4 more electrons. Do we do it like this? Well, no, we don't, because this is just an empty orbital, and it's at the same energy as the other 2p's. So, couldn't we just slide an electron over? Absolutely, we could. So here we go, and the way I like to do it is to go 1, 2, 3, and now that we've put 1 in each, we need a 4th electron. Let's just put it right here. Notice how I put all 3 as spin up before I put a spin down. You cannot do You can't do this. Notice how I paused. Even I can't write it wrong like this. You can't do this because, in this case, we don't have the electrons in singly occupied orbitals having the same spin. One is up and the other one's down, and they actually cancel each other out. Having the maximum possible spin is another way of viewing this second part of Hund's rule. So this is not valid, but this, for oxygen, is a valid application of Hund's rule. And finally, we have the Pauli exclusion principle. According to the Pauli exclusion principle, electrons occupying the same orbital must have opposite spins. So let's take helium, for example. Nice and simple, just 2 electrons, both in the 1s. If I were to put both electrons as spin up, there would be no distinguishing factor between them. They'd both be called electrons. They'd both be electrons that have the same charge, the same mass, the same 4 quantum numbers. Every single thing about these two would be exactly the same. So they couldn't exist as separate electrons. And as a result, we can't say that that is the way it would look for a helium atom, we would have to have a spin up and a spin down, because within this orbital, at least there is one distinguishing factor about these two electrons that in most every way are the same, but at least the spin is opposite, and that's what makes them different. I mentioned earlier that it is possible to violate the Aufbau principle in a higher energy state. The Pauli exclusion principle will never ever get violated simply because, again, the electrons wouldn't be different from one another, they'd be the same thing, and that just can't happen.